Hello and welcome to Design West. Today we are announcing the RX100. This is the first device of the RX100 family of microcontrollers. So the RX100 feature lowest power consumption of the RX family with the 100 microamps to megahertz, advanced on-chip peripherals with the built-in safety feature and the USB connectivity, USB host device and on the go. And then we have also a superior architecture and upward compatibility with the RX200 and the RX600. So the RX100 combined with the RX core delivers an impressive 3.08 core marks to megahertz, which is double the performance of similar Cortex M0 based microcontrollers that you can find on the marketplace. With the RX100 we cater to those who want to migrate from 8 to 16-bit microcontrollers to 32-bit microcontrollers, as well as to those who want to target applications such as smart home, mobile appliances, and the medicals, and so forth. One other feature that I would like to highlight is the fast wake-up, with the 4.8 microseconds wake-up time. And in the lowest power consumption mode, the RX100 features 350 nanoamp and wakes up from the mode in only 4.8 microseconds. So applications that will benefit from these features are sensors that needs to stay for a long period of time in the lowest power consumption mode, and then they have to wake up very fast. Other things that I would like to highlight is that the RX family use the same core across the whole spectrum of the 500 parts we are actually pushing on the market with the whole family. As a result, with the RX100, you can start from the low end, but at the same time, you can build a platform that can branch out to applications for higher performance kind of application with the RX200, the RX600, which again is fully compatible. What else to say? We have a plethora of tools, internal, developed by Renesas with the I2 Studio Eclipse-based developer environment, as well as third-party development environment such as IR and KPIT. And so let me now introduce you to Brandon Hussein, who is going to walk you through the RX100 demo. It's Brandon.
So in this demo, we're showing a typical application where the user wants to put the MCU into low power state whenever possible, and then wake up and do the processing that it needs. So, switching to this pie chart here, the yellow portion that you see shows the MCU in software standby mode. This is the lowest power mode where, as Carmelo said, we can pull 350 nanoamps. Currently, in this state, we are pulling around 700 because we are running the real-time clock, which will wake up the MCU. Every time the MCU is woken up, we jump into the blue region where we're running in middle speed operating mode. We're running at 4 megahertz off the low speed on-chip oscillator. During this time, we're taking ADC samples. When all the samples are taken, we jump up into the red bar, which is high speed operating mode. We're running at 32 megahertz off the high speed on-chip oscillator. At that point, we do all the processing we need on the ADCs and go back to sleep, where we're pulling around 700 nanoamps. Finally, here on the graph, we can see that over the period, we average around 67 microamps. And if you want any more information on the RX100, please go to the RX microsite at am.renesas.com/RX.